Hello and welcome to Esposende. We are now inside the natural park of the North Littoral of Portugal. This is a natural reserve and for its birds and also marine species. We are here because we are testing the WAVY-NOS drifters. WAVY-NOS is a project involving multiple partners, and we are developing drifters, so devices that float on the surface and have different sensors to acquire data from the water. Today we are testing 15 of those drifters. Some of them are equipped with echo sounders, others are equipped with cameras, and others with other phones. And our idea, and we came here to use these different technologies and sensors to acquire more data about the marine life and also the bathymetry of this park. We hope to have data of good quality, and we already know that we acquire some interesting data because we also have access to live data from the field. Right now there are drifters over there in the water. We are during the live tide, so they are moving slowly right now. And this is a collaboration from multiple partners. I'm here representing OceanScan. OceanScan is the coordinator of the project, and so we are also in charge of the coordination, of course, management, but also we are in charge of integration and also mechanical developments during the project. Together with me there's the partners from FIOP, also Inestec, and Instituto Hidrográfico in Norse from Norway, which is also one of the projects in the project. One of the partners in the project.
I'm here from UPORT LSTS. The work done on project WAVY-NOS is focused in two blocks. The first block, it was developed the board inside of the drifter. This board can control, monitor and connect all the payload inside of the drifters. And the second block, that was the onboard software. This onboard software relies on the OSS toolchain, and its main characteristics are, for example, monitor, control, configure and receive the real data from transmission to the user.
Tá, meu nome é Paulo Pinto, sou representante do Instituto Hidrográfico no âmbito do projeto WAVY-NOS. A nossa contribuição tem sido essencialmente testar os flutuadores em ambientes reais, organizar algumas campanhas, numa primeira fase definir casos de estudo e requisitos para os equipamentos que foram entretanto desenvolvidos no programa.
So, my name is Artur Rocha from Inestec. Our team has been developing the WAVY operation software, which is a web-based software for the planning and operation of campaigns like we are doing today. So during operation we can monitor the progress of WAVY drifters. We can consult the latest data, we can inspect data in real time so that we can take decisions of adjustments that we may need to do. After the campaign is done, we then perform data curation and processing and extraction of data.
Hi, my name is Rune Øyahan. I'm representing the Norwegian partner in WAVY-NOS, Norwegian Research Center. In the project, this project, we've mainly been working on identifying, purchasing and testing the echo sounder and the hydrophone instruments. And now we are here to also help in testing these on the WAVY-NOS drifters.
Hello, my name is Pedro Souza, and I'm here speaking on behalf of OceanScan for the WAVY-NOS project. And I will present the three different payloads that we integrated into the WAVY-NOS. First, we have a wavy imager that uses a bottom-facing camera to take images of the water column and the seabed. Then we have the wavy echo, which also uses a bottom-facing echo sounder for bathymetry measurements with backscatter data. And we also have here the wavy hydro, which uses a hydrophone. We can vary the hydrophone cable length to take measurements at different depths, and so we can record audio from natural sources or human sources like boats, for example. The three wavies are exactly the same. The only exception is the payload that is mounted on the bottom. So we have an antenna mounted on top which has GSM, GPS and can have Wi-Fi capabilities also. We have an LED for status feedback and also a vacuum port for a quick water tightness check before deployment. We also integrated a handle for easy deployment and recovery, and for these kind of these first tests we have a pole with a flag for easy recovery in sea or in river in this case.
We are here today at Museu Marítimo de Esposende. Outside we have a deployment of WAVY-NOS drifters at the Cabo do River. Right now the drifters are outside, we are somewhere in this location. There is a boat which is at this position and the drifters are slowly going into the river, because right now it's we are during a live tide. We are following these positions using a live map provided by Inestec, and all the technologies and all systems that you are seeing are part of the WAVY-NOS project. So now Mafalda from Inestec will give you a brief demonstration of what can be done using this tool on the web.
Hello, here we can see the platform that Inestec has been working on, the WAVY onboarding software. Here on the live map, as José has shown, we can see the real-time positions of the wavies outside, and by clicking on a marker you can see the last data that it has received, and on this corner here you can see the latest images captured by wavy imagers or the last recordings captured by the wavy hydrophones. The sound is very low, but you can also play it, and you can choose which wavies you want to see if you don't want all of them. On the history map you can see past launches. So yesterday we did a launch outside, and through this timeline you can also follow the wavies positions. So as you can see, we can see them drifting towards the sea. And after each launch you can build your own data sets for each type of drifter, And for example, in the data set of a WAVY imager, you can not only see the numerical data just collected, but also some screenshots and even transfer those images.
The idea for this website is not only to provide live access to the position, so we can, using a phone which is connected to the internet, we can know where the drifters are and recover them, but it's also useful for seeing the data that we collected in past events and also export it to required formats. So for each instance we receive information like of course the time of this sample, the geolocation, and more information such as it's difficult to see. Yes. So the speed over ground, the battery, also the temperature when it's available, the signal strength, because all these drifters are sending the data to the internet using a 4G module, so monitoring the signal strength may also be important. And sometimes, like you see on the bottom, they also send live samples, so they are not taking pictures all the time, they take pictures from time to time. Also some of these drifters are capable of classifying the data that they are collecting. So for instance, the camera drifters, which are the WAVY imagers, can send images only when they consider that the image is relevant. So to skip, for instance, images that don't have any data, of course they consider relevant, for instance, things which happen inside the boat, because usually what we consider that is not relevant is pictures with where you cannot see the bottom. Where you see elements which are inside the boat, they usually consider that to be relevant. So this is live. I think it's easy to understand. So what are the past tracks and what are the different drifters. So right now, the actual deployment, we have several imagers, so several drifters with cameras. We also have one with the echo sounder and one with an hydrophone. And probably these are now being collected because they are moving to the side.